Before we begin, take a moment to imagine this. You're standing on Earth, a small blue dot orbiting an average star inside an ordinary galaxy. Now imagine pulling away, faster and faster, past the moon, past the planets, past the sun itself. Our solar system shrinks into a thin disk. The Milky Way becomes a glowing spiral, and then even that starts to disappear. Out there, far beyond anything we can touch or travel to, exist structures so vast that words like big or massive completely lose their meaning. Objects made of trillions of stars. Regions so enormous that light needs millions, sometimes billions, of years just to cross them. These are not theories or science fiction. They are real, observed, measured, and quietly existing in the darkness of space. In this video, we're going on a journey to explore the 10 largest objects ever discovered in the universe, from colossal galaxies to structures so vast they challenge our understanding of cosmic scale itself. And as each one appears, you'll realize just how small everything we know truly is. If you enjoy calm, immersive journeys through space and the mysteries of the cosmos, make sure to subscribe, because out here, the universe never ends, and neither does the wonder. Our journey begins closer than everything else on this list, yet still impossibly far. Long after the last planet fades into darkness, beyond Pluto, beyond the Kuiper Belt, there exists a vast and invisible shell surrounding our solar system. Astronomers call it the Oort cloud. It is not a solid object. It is not even something we can see directly. The Oort cloud is a theoretical region filled with trillions of icy remnants left over from the birth of the sun. These frozen objects drift slowly, loosely bound by gravity, forming a sphere that stretches nearly 1 light-year in every direction. To understand its size, imagine this. If Earth were the size of a grain of sand, the Oort cloud would extend kilometers beyond it. Light leaving the sun would take months just to reach its inner edge, and years to cross it entirely. This distant region is thought to be the origin of long-period comets, ancient travelers that occasionally fall inward, briefly lighting up our skies before vanishing again into deep space. At this scale, the sun no longer dominates the sky. It becomes just another star among billions. And yet, as vast as the Oort cloud is, it barely registers on the cosmic scale we're about to explore. Pull back further, much further. The Milky Way is a barred spiral galaxy containing more than 100 billion stars, along with planets, nebulae, black holes, and massive clouds of gas and dust. It stretches roughly 100,000 light-years across. Light, moving at the absolute speed limit of the universe, would still need 100,000 years to travel from one side to the other. At its center lies a supermassive black hole, Sagittarius A star, holding millions of times the mass of our sun. Around it, stars orbit in slow, graceful arcs, taking millions of years to complete a single revolution. Our solar system sits far from the center, in a quiet spiral arm. One system among billions, completely unremarkable from a cosmic perspective. When we look at the night sky, we see only a thin slice of this galaxy. The glowing band of the Milky Way is not a cloud. It is the combined light of countless distant stars. And still, this entire galaxy, our entire cosmic home, is just one small structure in a much larger universe. Now, imagine placing our Milky Way next to another galaxy. Not a neighbor, not a rival, but a true giant. IC1101 is one of the largest galaxies ever discovered. This massive elliptical galaxy spans an estimated 5 to 6 million light-years in diameter. That means you could line up 50 Milky Ways side by side and still not cross its full width. IC1101 contains trillions of stars, most of them old and dim, orbiting in a vast, smooth halo. Unlike spiral galaxies, it lacks defined arms. Instead, it forms a colossal sphere of starlight, dominating its surrounding space. At its center lies an enormous black hole, likely weighing tens of billions of solar masses, anchoring the galaxy through gravity alone. If Earth were placed inside IC1101, our entire galaxy would disappear into its outer glow. And yet, even this monster is only one piece of something larger. Galaxies are social. They gather into massive gravitational families known as galaxy clusters, structures containing hundreds or even thousands of galaxies bound together by gravity. Some of these clusters span more than 10 million light-years. Inside them, galaxies race around at incredible speeds. Hot gas fills the space between them, glowing faintly in X-rays. Dark matter, completely invisible, provides most of the gravitational glue holding everything together. Galaxy clusters are among the most massive structures in the universe. Their gravity is so strong that it bends light itself, creating gravitational lensing that allows astronomers to see even farther into space. Entire galaxies collide, merge, and reshape over billions of years inside these clusters, and still, clusters are only neighborhoods in something far greater. Zooming out again, we find that galaxy clusters themselves are arranged into enormous regions called superclusters. The Virgo supercluster is one such region. It contains thousands of galaxies and stretches over 110 million light-years. Our Milky Way is just a tiny part of it. Unlike galaxies or clusters, superclusters are not tightly bound objects. They are loose concentrations of matter, regions where galaxies are slightly closer together than average. For a long time, astronomers believed superclusters represented the largest structures in existence, but deeper observations revealed something even bigger. In 2014, scientists redrew the map of the universe. They discovered that the Virgo supercluster is part of a vastly larger structure called Laniakea, a supercluster spanning more than 500 million light-years. The name means immense heaven, a fitting description. Laniakea contains over 100,000 galaxies, all slowly flowing toward a mysterious gravitational region known as the Great Attractor. From this scale, galaxies become mere points. Motion becomes the defining feature. Everything drifts, slowly, inexorably, across cosmic time. If you could see Laniakea from the outside, it would appear like a vast river of galaxies moving together through space. And still, this is not the end. Stretching across space like a scar in the universe lies the Sloan Great Wall. This immense filament of galaxies spans approximately 1.37 billion light-years, making it one of the largest known structures ever observed. It is so large that its existence challenged early cosmological models, which predicted the universe should appear uniform on very large scales. The Sloan Great Wall is not solid. It is made of thousands of galaxy clusters and groups, arranged in a vast sheet-like structure. Light needs more than 1 billion years just to cross it. At this scale, human history becomes meaningless. Entire species rise and fall, while a single photon continues its journey across this cosmic wall. Larger still is a structure that pushes the limits of what scientists believe should be possible. The Hercules Corona Borealis Great Wall is estimated to stretch an astonishing 10 billion light-years across. It was discovered not through direct imaging, but through patterns in distant gamma-ray bursts, brief flashes of energy from the most violent events in the universe. This structure is so large that it challenges the principle that the universe should be roughly uniform at extreme scales. Scientists are still debating its true nature. Is it a real structure, or a statistical illusion, or evidence that the universe is far more complex than we imagined? At this size, the universe begins to feel uneven, almost unfinished. Now, we step back to the biggest thing we can actually observe. The observable universe is a sphere approximately 93 billion light-years in diameter. It contains every galaxy whose light has had time to reach us since the universe began expanding. Within it are hundreds of billions of galaxies, trillions of stars, possibly more planets than grains of sand on Earth, and yet, this is not the entire universe. Beyond this cosmic horizon, space continues, but its light will never reach us. Those regions exist forever beyond our view. The observable universe is not a boundary. It is a limit imposed by time itself. The largest structure ever discovered is not a single object. It is the cosmic web, a vast network of filaments made of dark matter, gas, and galaxies, stretching across the entire observable universe. Galaxies form along these filaments like dew on spider silk. Between them lie enormous voids, regions nearly empty of matter, sometimes spanning hundreds of millions of light years. This web is the universe's hidden architecture, its skeleton, its foundation. Everything we see, every galaxy, every cluster, every wall, is woven into this immense structure. And beyond it, there may be more universe still, from distant clouds of ice surrounding our sun, to galaxies, walls, and cosmic webs stretching across billions of light years. The universe is not just large, it is humbling. And every discovery reminds us that while we are small, our curiosity is not. If this journey through the largest objects ever discovered made you feel even a moment of wonder, make sure to subscribe to Astri-X, because the universe is vast, and we've only just begun to explore it.